Okay, I'm going to do a quick guide to statistics so that you are prepared to do any of your IAs if you're struggling with anything. So statistics, we're looking at, just ignore the kids in the background, they're jumping on the trampoline. Okay, 3 main things that we could be looking at. We could be looking at having 2 groups and testing 1 variable, meaning that you'll have 1 group that has 1 particular independent variable applied, and then the other would be the control group. So 1 group control, 1 group with the variable. This can also look like having 2 separate groups that don't seem to be related. And in this case, you're looking at having 25 individuals or 25 trials per group. And the test that you would be doing on this would be a t-test, and you'd be looking for standard deviation as well. So when you go to graph it, it might look something like this: Group A, Group B, and then you always, always, always include error bars, and you tell what those error bars represent, typically standard deviation, which you would have to calculate. Okay, second type that we could be looking at is where you have your independent and dependent variables are both continuous. So continuous, independent, and dependent variables. So when you go to graph it, when you go to graph it, this is continuous along your x-axis, this is continuous along your y, and maybe you get something that looks like this. Now in this case, you're plotting all of your data points. You're finding a regression line or a line of best fit. And this can be done on Excel. You might need to look it up. Now, the important thing here is that this is raw data right here that's being graphed. You're finding the line of best fit, and that's part of your calculated data. There's your best line. And you're finding what is the slope of it, and that tells you what is the relationship between the x and the y variables. And then you're also saying, what is the r value? And the r value is how well values stick to the line. If you had something that looked like this, then your r value would equal 1.0. If you had something that had absolutely no correlation whatsoever, then your r would equal 0, and hopefully you would see something in between that. So significance in this case is above a 0.90 or below a negative 0.90. A negative would just indicate that there is a direct negative correlation. And the third type, which is probably what you're the most familiar with, is when you have 5 groups and you do 5 treatments for each group. So in this case, you've got 5 discrete independent variable treatment levels. A, B, C, D, and E. And you've got a continuous Y variable, that's your dependent. So each of your values, if I were to just plot them as points, would look something like this. But again, we never just plot the raw data. We're always going to do something with that. So in this case, okay, sorry, I had to pause. Okay, and now they're singing. Anyway, in this case, the manipulated data that you would do is find an average for each group. For example, take these 5 data points, find the average, and that is what you plot. You also need to find the standard deviation for each group. And that is more than likely going to become your standard deviation is going to become your, error bar there. Okay, something like this. And of course, you wouldn't include the dots anymore. Those would be deleted because that's your raw data. Okay. So just as a recap, remembering that for all of your IAs, for the data analysis part, you've got your raw data. that's going to be some kind of table. And I'm going to show you a quick little warning that I see a lot of students do, is that they have trial 1, trial 2, trial 3, and they include whatever their data points are just at random, right? So the first time they try to find heart rate, for example, they'll write down the heart rate under, no running as your treatment group. And they get 72 beats a minute, and then they do it again at 76 beats a minute, et cetera, down the line. And then they do 5 minutes of running. And then they get some data, and then they do 10 minutes and get some data, etc. And then they think that because you did trial 1, that these 5 sets of data, right, because you'll have 15 and 20 minutes, so these 5 sets of data are somehow related, and they'll make those into a line graph, and that these 5 trials are somehow related, and they'll make that into a line graph. That is wrong. That is wrong. Your trials are just, we're going to put those in quotes. They're not really trials. They're not really telling you anything. The only thing that they're there for is so that you can indicate. Okay, sorry, lost my train of thought. As I was saying, though, this trial 1 doesn't mean anything. It was just to help you figure out that each of your different sets of data had 5 trials. However, what's important is how it's aligned this way. So this data is what you'd find an average for and a standard deviation for. And when you find the average and standard deviation, or when you're finding your regression line or your R value, or when you're finding your P value if you're doing a t-test, or whatever the statistical test is, that part right there is your aspect 2. Okay, so here's your raw data. Here's your manipulated data. And the last thing that you always have to have is aspect 3, which is taking what you've done from aspect 2 and putting it into some kind of visual representation. A graph, a line graph like this, a bar graph, and always show that error bar. That error bar is going to be what you really talk about during the conclusion and evaluation, because during the conclusion and evaluation, you refer back to your error bars and say, look, I had a small error, which means that my data is more likely to be significant, or whoa, I had these ridiculous error bars that actually went into the negatives. Probably not significant because my data was so well spread out. So make sure you refer back to your aspect 3 of data, meaning your graphed data. You can usually write something like, as you can see in figure 1.1, or some baloney like that. The error bars were very high and therefore not likely to be significant. Okay, so that needs to be in your CE. Don't forget that. Okay, hope that helps.